congruent triangles, if two triangles were congruent, listen, they were exactly the same. And back then I used the thing of saying copy, paste, right? Exactly the same thing. Now, so at congruent triangles, the size is the same, the angles are the same, the sides are the same, everything. Right? Okay, now we get to similar triangles. So you will see here, they are not exactly the same, but they are similar. No. So I used, okay, first things first, the sign that we use is now, at congruency, it was the 3 stripes like this. So for similar, it's going to be 3 stripes like that. Okay. Then, now, these similar triangles, they are not the same, but there is something that is the same for both those triangles. So it's almost like looking at a picture and then you guys zoom in or zoom out. No, so the size will be different of these two triangles. No, so that's not the same, the size, but the shape will be the same. So we have got 2 rules. Remember at congruency we had 4 rules, no? So to prove that 2 triangles are similar, we've got 2 rules that we use. The first one is angle, angle, angle. So you prove that all 3, the angles are the same. Because even though the length of those sides might be different, the angles can still be the same. No. Okay, so that's the first thing. The alternative is, or the second method of proving that 2 triangles are similar, will be sides proportional. Because if you think of a picture, if I've got a picture of your face and I zoom in to see your nose, is it only your nose getting bigger and the eyes and the ears and the mouth, they stay small? No. Everything reduces, or everything enlarges. Does that make sense? No? So when you zoom in, you're making everything bigger, but it happens in proportion. So it's not a distort picture. No? Okay, so that is the second way that we're going to prove that these 2 triangles are similar. We're going to say that their sides are proportional. So the one triangle, if I enlarge it, all the sides will be 4 times bigger.
Then in this case, can you say sides?
Yes, yeah, we're going to get to that just now. Or if I've got a big triangle and then it's reduced, then all the sides will be reduced to 6 times smaller or 5 times smaller. And that 6 or 5 will be my scale factor of which I am reducing or enlarging. Okay. So whenever they talk about a scale factor, you know that is with how much each of those sides are increasing or decreasing. Okay, so let's look at our first example. The first example here, I am giving you 2 triangles, triangle ABE and triangle ECD. And you've got to prove that they are similar. Okay, so we've only got 2 methods, either all the sides or all the angles. Am I giving you any sides here? No. So would I be able to use that option? The rule of sides proportional? No. So then we have to opt for the option where we use the angles. Okay. So who can tell me which angles here will be the same? A and D. Okay. So angle A will be equal to angle D. And just like we had at congruency, we've got to give a rule. Now have a look. How did he know that? Have a look. What am I giving you? Parallel lines. And whenever we have parallel lines, we can look for either F, a U, or a Z. He saw a Z. So angle A and angle D. So we call that alternate angles. Okay, right. So I've got to say my reason, alternate angles. And we've got to state the parallel line. So AB is parallel to CD. Okay, So I've got one angle.
Oh, and angle 1 is equal to angle 2, B1.
E1.
E1.
Yes. Okay, so angle E1 is equal to angle E2. Why?
Vertically opposite.
There we go. They are vertically opposite angles. Yeah, Sema?
Angle B is equal to angle C.
Good. Angle B will be equal to angle C. Just for those of you that's not seeing it, have a look. There's the Z again. So B and C. Does everyone understand that one? Okay, so again I'm going to say alternate angles because AB is parallel to CD.
Ma'am, in the similar triangles, must there also be 3 reasons why?
Yes, yeah. Because you either use 3 sides or 3 angles. Now, usually, I just want to say that regarding the angles, if 2 of the angles are already the same, doesn't it make sense that the third one would obviously be the same? No. So you could even only prove 2 of the angles. Okay. Alright, so then we've got to end with, therefore, triangle ABE is similar to triangle, and what was the same as A? D. Okay, what was the same as B? So C, E. And my reason will be angle, angle, angle. 5 marks, people. Easy peasy, no? Right. Any questions? Okay. Can I skip?
Yo, it's me. It's the change. It's the change. Then you can see.
Hands up, we're still copying? Alright, the next one, I am giving you 2 triangles again. Oh, you're still busy. Oh, Malcolm, were you still busy? Sorry, excuse. Jy sit dood still. Did he put up his hand? En ek het dit eers gesien nie. I'm sorry. Okay. Okay, so the next one, listen. Next one, I'm still giving you 2 triangles, but in this case, can you see I'm not giving you any angles? I'm only giving you sides. So that is my clue that I'm obviously going to use the sides proportional option. Hey, I'm going to use that to prove that they are similar. Okay, so we first have to state in triangle ABC and triangle DEF. Now, when we're working with the sides, you will see here at the bottom, I wrote down the 3 steps that I use. Now, if you maybe switch them around, it doesn't matter. But at my step 1, I start by looking at the longest side of each triangle. Okay. And what I mean when I say you can switch them up is, I mean, if you want to start with the shorter sides, then that's fine. No, so it doesn't really matter. As long as you use longer sides together and shorter sides together. Okay, so when I talk about the longest side, in the big triangle, ABC, which side there is the longest one? Look, have a look, 45, 60, and 90. So the 90 is the bigger one. Okay, so I'm going to say B, C. Now, I'm going to take the longest side of both those triangles and I'm going to put that in fraction form. I'm going to say BC over. Now I want the longest side of the smaller triangle. Now I have got 15, 20, and 30. Which one is the longest? The 30. What do I call that side? EF. So can you see I take the longest side of the big triangle and longest side of the small triangle. Okay. Now let's go substitute in. BC is 90 and EC is 30. And that simplified gave me how much? 3. All right. Okay. Yes, that's exactly how we're going to write it. Now people, if you will see over here, I put the biggest triangle at the top of my fraction and the small triangle at the bottom of my fraction. You could have switched those around if you want to use small triangle over big triangle. But then you've got to do the same at the next 2 steps as well. Okay. Right, so I'm going to stick to big triangle at the top, small triangle at the bottom. Okay, now my second step is use the 2 shortest sides. Okay, what's the shortest side of that triangle ABC? 45. So I name that AB. Okay, over. What's the shortest side of the small triangle? DE. Okay, so let's go substitute in. AB was 45 and DE was 15. If I simplify that, it gives me 3. Now you guys can already see a pattern. No.
Is the reason given?
No, there's no reasons here. 3 and 3. No. Okay, now listen. Now you can see why I can't use big triangle at the top and small triangle at the bottom and at the next one switch it. Because then I'm not going to have 3, I'm going to have a third. Do you guys see? And then you're going to think they're not similar. So whatever you use the same format for both of these 3 steps. Okay, right. Now, we've used the longer side. We've used the shorter side. So now there's one remaining side at each one of those triangles, right? For the big triangle, it was AC. For the small triangle, it was DF. Okay, let's go substitute. NAC was 60. Oh, nee, dis te lelik. And DF was 20. And that simplified gave me 3. And again, we end up with a 3. Now, only when these 3, those, are the same. So then these 2 triangles are similar because it means that the small triangle enlarged by 3 will give me the big one. Or other way around, big triangle 3 times smaller or reduced will give me the small triangle. Does that make sense? Okay, right. So then I can say therefore, and order is very important here. So triangle, and let's use big one, middle one, and then small one. Okay, so I'm going to talk about B, C, E. BCA. Okay, you guys good? BCA is similar to triangle. Okay, now do the same. Big one, middle one, and then the small one. Okay, so E, F, D. Does that make sense?
So, ma'am, the way you started your reasons has been the way you...
No, it doesn't matter. So if you maybe said A, C, B, then over here you would have D, F, E. Okay, so if you wanted A, B, C, then you use shorter side and then longer side. So then it would be D, E, F. Okay, right, so what's my reason? Sides. And you don't have to write out the full proportional word, just sides prop. Okay, any questions? Yep. People, I just want to quickly show you that's not the case here. But let's say I had 3 there, 3 there, and then 2 here. because these three numbers are not the same, that one is most different. No. Would they be similar?
No.
So then all we do is
Line
that.
Oh.
Not similar.
The reason no. Okay, so
No, you don't need a reason. It's just not similar. Okay. Does that make sense? Okay. But we don't usually ask that. Just so you know. All right. Anyone still copying? Yeah. We say yes.
I'm done now.
Okay. Okay.
I'm done.
Are you done? Okay, so people, your homework. Exercise 13.8, which is on page 139. Do number 1 and 2.